So in this video, we'll continue to make our way through SAT practice test number 8, section 3. So we've got the last 5 non-calculator multiple choice questions to discuss here. Start with number 11. And so in number 11, they give us the graph of some polynomial, and they ask us which of these equations could they be showing us the graph of. And so what I notice here is I notice the x-intercepts, or the zeros of this polynomial, are -3, 0, and 2. If I factor the polynomial and solve the equation after setting it equal to 0 by factoring, what I should see as my factors, if I have an x-intercept of -3, I should see x plus 3 as a factor. We have that in choice A, we have that in choice B, we don't have that in choice C, we don't have that in choice D. Now the reason why I'm keeping A and B and ruling out C and D is because if I set these two items in choice A and B equal to 0 and solve for x, I get -3 as the solution. I would get +3 as my x-intercept or as my solution for these bottom two options. If you look at the other two locations, 0, well, setting x equal to 0 gets me 0, setting x squared equal to 0 gets me 0, and 2, setting x minus 2 equal to 0, setting x minus 2 equal to 0, both of those give me those appropriate answers. So we can't really narrow down between A and B any further. So here's the other thing that you have to recognize here. The graph changes directions at 0. And if you've looked at polynomial graphs in Algebra 2 and pre-calculus, you've probably spoken about what's called a repeated root of a polynomial. So a repeated root is a place where the graph of the polynomial touches the x-axis in one location but quickly changes directions. And that's what happens on this graph I'm showing you over here at the x value of 2, but it's what happens on the graph of the polynomial they're presenting us with at 0. And so what that must mean is that 0 is a repeated root of the polynomial, since the graph doesn't actually cross the x-axis there. It hits the x-axis and then quickly changes directions. And what that's going to indicate to us about the equation is that there must be an exponent on the factor that produces that 0 for the function. And that is what the case is with option B. We don't have the exponent present here in option A, which is why our answer here is going to be option B. So we had to use the notion of a repeated root, and what that tells us about the equation, exponent on the factor that produces that root, in order to narrow it down between A and B. Number 12 gives us this equation, 2a divided by b is equal to 1/2. What's the value of b divided by a? This is a pretty common tactic for the College Board to use on the SAT. They don't want you to be able to do something by guess and check, so they don't ask you to solve for a variable. They ask you to solve for some new expression, in this case b divided by a. So my strategy anytime I see something like this is just to basically manipulate the equation until I can get a b over a within it. And so I'm going to get rid of the fraction first. So I'm basically going to treat this like a proportion. I'm going to cross multiply, which is going to give me 4a is equal to b. And then once I'm here, once I've cross multiplied, it's pretty easy, hopefully, to recognize how you're going to get to b divided by a. If I just divide both sides of this equation here by a, I get b divided by a on the right-hand side, and b divided by a pretty clearly is 4. Number 13 here tells us something about oil and gas production in a certain area, dropping from 4 million barrels in the year 2000 to 1.9 million barrels in 2013, assuming the oil and gas production decreased at a constant rate. And the reason why this phrase is there is because a line increases or decreases at a constant rate. Polynomials do not. So we're going to be modeling this relationship with a line, since we're decreasing at a constant rate, or we're assuming that it decreased at a constant rate. Which of the following linear functions best models the production in millions of barrels t years after the year 2000? Now if you look at all these options are essentially y equals mx plus b form. Y is being replaced by f of t, x is being replaced by t. All of the y-intercepts are the same, and that makes sense. If I'm starting this graph at the year 2000, where I had 4 million barrels being produced, I'm going to start the graph at a y-intercept of 4, and then 13 years later, my graph is going to have to drop to 1.9 for the y value or the function value. So I'm going to have to get from 0, 4 to 13, 1.9. Well, my rise there is negative 2.1, and my run is 13. So this would be my slope. Now, if you look at your options, there are two options that are really easy to rule out. These do not have negative slopes. These graphs will not decrease. Those will increase. Now, option C and option D are the ones that we're going to have to narrow it down between. If we just multiply the top and bottom of the fraction that is right here by 10, I get negative 21 for the numerator, I get 130 for the denominator, and that's what's going to hopefully allow us to see that we are looking at option C. Number 14 asks us to determine how many solutions there will be to the system of equations. Now here's one thing that you have to remember about the solution to a system. A solution to a system is an x and a y that satisfies both equations. That is one solution, even though there are two elements to that solution. So we're going to have to kind of be cautious of that whenever we get to the end of this. So I look at this second equation. We've got a lot of different options we can use to solve systems. We can use matrix options, Kramer's rule, solving by graphing, solving by substitution, solving by elimination. Anytime I start to see exponents like we have here, I would want to either use graphing, but I would want to have a calculator accessible in order to use that option. We don't here. My fallback, if I don't have a calculator in play, would be to use substitution. And so when I think about the method of substitution, I think which of these equations would be simple to solve for one of the variables. Well, I can solve the second equation for y pretty easily if I add 5x and subtract 8. And that's going to tell me that y is equal to 5x minus 8, and I can replace the y in the other equation with 5x minus 8. So if I do that, and I'm just realizing as I'm discussing this that there was an easier option. What I've done is still going to work. It's not too much worse than what I just realized would have been a little more efficient, but if you don't solve this one the way I'm doing, you should still get an equivalent answer to what I'm about to get. But anyhow, I substitute 5x minus 8 in place of the y, and that leaves me with the equation that you see written out right here. I see that equation has an exponent. It's a quadratic equation. On a non-calculator question, am always going to attempt to solve quadratic equations by factoring. It doesn't work every time. You might have to use the quadratic formula. You might have to use completing the square. A non-calculator question designed by a textbook, the college board, your teacher, your professor, it's extremely likely that it's going to be able to be solved by factoring if no calculator is in play. And so with that in mind, I'm going to get this equation to be set equal to 0. So I'm going to add 8 to both sides. If I add 8 to negative 7, that leaves me with positive 1. I'm going to subtract 5x from both sides. Positive 3x minus 5x leaves me with minus 2x. When I try to solve this by factoring, I need first times first from my reverse FOIL process to equal x squared. I need last times last to equal positive 1. So you see I've picked x and x for first and first, negative 1 and negative 1 for last times last. If you check the outer and inner multiplications from FOIL, that does give you the negative 2x that you see in the middle. If you set either of these sets of parentheses equal to 0, the only solution that you get is 1. If I plug 1 back into one of the original equations, or I'm plugging into this y equals 5x minus 8 equation, I can figure out that the y value that corresponds to the x value of 1 is negative 3. Now, like I said before we got into this, it looks like I have two solutions here. I got this number for x, I got this number for y, but a solution to a system is an ordered pair. We do only have one ordered pair. 1x, 1y that goes with it. There is exactly one solution here. Now, an alternate form of this question, one that might have two solutions, let's say that this set of parentheses, rather than x minus 1 like we got, let's say it was different than this first set of parentheses. Let's say it was x minus 5. I would get 1 and 5 as my x values, and I would get negative 3 and some new y value. That would be two ordered pairs, two unique ordered pairs that satisfy the system. So hopefully you realize why we're going with option C there. A solution to a system is an ordered pair, an x and a y that satisfy it. It's not just the number of individual unique values that we got for any of the variables. So one solution here because we only got one unique ordered pair that satisfies the system. Last question in this video will be number 15. This problem presents us with two functions, g of x and h of x. They ask us to find the value of h of 0. So when you're trying to evaluate a function at a certain value of x, you're literally just putting that value of x in place of the x's in the function. So when we do that for h, what we get is we get 1 minus g of 0. Well, that causes for us to have to go and figure out something else. Well, what's g of 0? Well, I use the same strategy with g as I was using with h to start off the problem, and that's to put 0 in place of the x's in g. So when I do that, 2 times 0 minus 1 gives me negative 1. G of 0 is negative 1. Therefore, h of 0 is 1 minus negative 1, which is going to give us an end result of 2.